Hello, geometry folks. Today I am gone. I know, sad face. But we only have a 40-minute class today, and you should have a sub teacher. So the sub should have the handouts for you. So we should have watched a video yesterday, or over the weekend, I should say, about algebraic proofs, and we're going to add some more properties into your notebook from the handout that the sub gives you. We're going to glue them into your notes, and then we're going to get started on your homework in this video. So before we get our notes into our notebook, let's just talk with a friend to answer these questions. So I'm not going to go through them, but you guys can go through them. So if you want to pause the video right now to talk to a neighbor and answer these questions, go for it. If you want to skip ahead, that's perfectly fine with me. So this yellow half sheet, my slide's yellow and your notes should be yellow. You should glue it into your notebook. So we're talking today about some algebraic properties. So we all know that the addition property of equality is when we just add something to both sides of an equation. So just like you saw in your notes from the video last week, when we added stuff on either side, we just called that the addition property. And then the subtraction property is if we subtracted on both sides, multiplication property is if we multiplied on both sides, and the division property is if we divided on both sides. The new ones to us are the reflexive, symmetric, and transitive properties. So the reflexive property can be stated like this: x is equal to x, or something has to be congruent to itself. So just like on the last slide, Benji was congruent to himself because he's still Benji. So it'll make probably more sense actually when we get to the geometric proofs on using this property. The symmetric property, all it's saying is that if A is equal to B, then B has to be equal to A. Or order doesn't matter. If the A is lifted on the right or the left, equality is maintained. So I think on the last slide we said that if Twyla and Sally were sisters, it didn't matter if we said Twyla is sisters to Sally or Sally is sisters to Twyla. And then the last one is the transitive property. We're saying if A is equal to B and B is equal to C, then A has to be equal to C. And that was like the first example with Benji, Twyla, and Sally. So on the previous slide, if you would have talked through those questions with a partner, those were all these properties in real life. And then substitution is something that you should know from solving systems, but if you want to write this example on your little half sheet, you can do that. We'll write an example. If we have y is equal to, I don't know, 3x plus 5, I'm just making up this example off the top of my head, and we have 2y plus 4x is equal to 10. What we're saying with the substitution property is since y is equal to itself, according to the reflexive property, we can plug in 3x plus 5 into the y in the other equation. So we could do something like this: 2 times 3x plus 5 plus 4x is equal to 10. That would be the substitution property. The point of this example is to show the step of substitution and not necessarily solve. So if you wanted to solve, by all means, go ahead. You can solve this two equations or this system that I just randomly pulled up off the top of my head, but we don't need to solve that. We're just showing this step. That's the substitution step. So all four of these are kind of new to our algebra brains as far as properties, okay? So the sub should be giving you a white sheet of paper with some problems on it, and we're going to go through number one together. So in our unit right now with geometry, we are going to start proving things. And before we start proving stuff in geometry, in order for us to get used to this two-column proof that we're using, where one side's all the statements and one side's all my justifications or my reasons, that's going to help us build the rubric or template, if you will, for proofs before we move on to geometric proofs. You guys, algebra is something that most of you are pretty familiar with and pretty strong with, so I wanted to start proofs here so that we know how to prove things and why we're proving things, so that when we move on to geometry proofs, it's not going to be such a shock to you as what proofs are. So this is number one on your homework. When we're trying to prove something, they give me some statements, to start with, and then they give me the answer, if you will, and say, prove to me that b is equal to 2. So our goal in proofs isn't necessarily to find the answer, because the answer has been given to us in the proof statement. We have to show our justifications of how we got b equal to 2. So we're going to start with our two column, our two columns, our statements and justifications. Sorry, I had a brain fart there. So we always start with the givens. A is equal to 2b plus 6. That was given to us. And a is equal to 9b minus 8. That was also given to us. And it's now on step 3 that we have to manipulate or do some algebra with the given to figure out what our next step is to get b alone. So they did the steps for us on this page, and we have to show the reasoning that they did. So they jumped from the given statements and said 2b plus 6 is equal to 9b minus 8. Well, we know if we start on the left-hand side of statement 3, we have 2b plus 6. We knew from the given that that was equal to a, but we also knew that a was equal to 9b minus 8. So by the transitive property then, we got rid of the a and just said 2b plus 6 is equal to 9b minus 8. Sorry. The transitive property was saying if something is congruent to a and that something a is congruent to something else, then we know that this is equal to that. So that's how we got from the given statements to step 3. Then in our next step, they did 6 is equal to 7b plus 8. So we are now at 2b plus 6 is equal to 9b minus 8. Well, it looks like they subtracted 2b from both sides, so they got 6 alone, and they had a 7b minus 8. So I'm going to call that the subtraction property. And then they got the b's alone on the right side, so they must have added 8 to get that 14 on the left-hand side. So that means that they got to the addition, they used the addition property to get statement number 5, 14 is equal to 7b. And then they just divided by 7 to get to step 6 or statement 6, which was 2 is equal to b. And this is something that you guys might think is tedious, but from step 6 to 7, they did the symmetric property because they want this statement to read exactly like the proof statement, even in the order. So they just switch the 2 and b around, and we know that b is equal to 2 because of the symmetric property. So please get those practice problems done. I will be posting an answer key on Google Classroom, and know that that's just a tool to help you check to make sure you're doing it right, and we'll go over questions that you may have on Wednesday if you have any. Thanks for taking such good notes. See you soon.